So to open up our last session, we have Sergii. So Sergii is from Kamu. Kamu has been supporting our product team, working very closely with them to get molecule labs off the ground. So we're very grateful for them and their help. Sergii is very passionate about open data and citizen science. And so, yeah, that's kind of what led him to co-found and become the CEO of Kamu. Welcome to the stage.
Right, hello everyone. It's an honor to present to you today. So as you saw from multiple presentations, data is really fundamental to a lot of data DAOs that presented today. And let's talk about data. So I've been in data for 15 years as a senior architect and building data pipelines for big tech companies. My co-founder, Nilay, who's also here today, she's a professor of ML and AI in Simon Fraser University. So we joined our forces to use latest enterprise and Web3 technologies to unlock global collaboration on data processing. We started a company just right when COVID hit, and pandemic was widely regarded as the failure of global data infrastructure. You might remember in May 2020, UK was still using phone, pen, and paper to tally up all the results of the lab testing. And they later admitted that the data they were collecting for like 3 months was completely unreliable and shouldn't be used for any research. In October, they upgraded to a shared Excel spreadsheet file that overflowed and 16,000 cases were lost. The people like you, the volunteer researchers, basically saved the day and were providing observability in the early days of pandemic onto how the pandemic was evolving. For example, in 2021, COVID tracker project in the US logged 20,000 hours of volunteer time on data entry alone. So this is like 10 years of full-time work to integrate data from multiple sources, from web pages, press releases, from different municipalities, to bring it all together. So this is obviously hugely inefficient, but to us it was a striking example of this global collaboration on data entry and data sharing, data processing. Fast forward to today, all these efforts are undone. Data sets are either not updating or gone, databases are offline, websites shut down. So it's really sad that it took us a global pandemic to just start collecting these basic metrics like hospital bed occupancies or how many people were admitted with different diseases into the hospitals. But it's even sadder that we failed to sustain these efforts. So to me, it's almost like a verdict to every effort that comes after, like, oh, we want to track the spread of the other diseases. It's almost like a verdict that unless something big changes, this is not going to be sustainable. So we're seeing a huge systemic problem. After dozens of open letters, petitions, hundreds of calls for funding, there's still little results. So to me, it's clear that we're just hitting the limit of human capacity, and we need to solve it with better technology. And the core thesis of my talk today is that this is actually one big problem. Different sectors just experience different aspects of it more acutely, and they've developed niche solutions to address them with no common foundation, the foundation that is needed for efficient data exchange. And we believe that there is no shortcuts left. Like if we want to solve the research data problems today, we will need to solve the whole thing. We will need to fix the global data economy. So we have like 10 minutes, so let's try. Paraphrasing Kuhn, the best way to untangle and dismantle the established way of doing something is to find these clear anomalies and pull on them like loose ends of the sweater until the whole thing unravels. So the first anomaly is reproducibility and dynamic data. 90% of researchers believe that there is a reproducibility crisis going on. And we have many tools for the analysis, like dependency pinning, containers, reproducible environments. But the source data, the inputs of the whole process are often non-reproducible. For example, it's reported that 80% of government data perpetually loses history. It's mostly due to bad modeling, some poor infrastructure, but sometimes even censorship, where data sets can just disappear by the decree of someone. How researchers are dealing with this, they do snapshots, right? Before they start their research, they copy the data from original source into some research data management platform like Dataverse or Zenodo. And as a result, we have many copies of similar data existing in dozens of different portals that is always outdated, unclear where it came from, it's creating a systematization nightmare. We're creating data swamps. None of the COVID-19 data, very interestingly, was in RDMs when the pandemic was ongoing. RDMs are basically treating data as books in a library where you put it on a shelf and don't touch it anymore. But this data was changing daily, and the version file model just didn't fit for it. It was uploaded later into RDMs just for archival purposes. We believe that most of the world's data is dynamic. Like finance, IoT, blockchains are just very extreme cases of it. But even archaeological data sets continuously evolve. They're extended and revised. So we believe that data should not be treated as books in a library. Data is a rocket fuel of our society, and this fuel should flow. The solution are ledgers. They existed for millennia. We no longer need to write them on clay tablets. And this is a perfect tool that combines archival and real-time. So the ledgers are append-only. So this means that if you have a position on a ledger, this is a stable reference that you can publish a paper with. If you need to do a retraction or correction, you do it explicitly afterwards. So we're talking about pushing reproducibility towards the source, towards the publisher of the data. We can use tools like signing to make the data tamper-proof and assign accountability to the publisher for the data that they're providing. And instead of copying, we use replication. It's similar, but different in the sense that replicas always point to the source of where the data actually came from. So we built Kamu CLI as our first product. We call it Git for dynamic data. And its purpose just to make working with ledgerized data super easy. So you can ingest data from external sources into these ledgers. You can explore data with embedded SQL, embedded Jupyter, and very easily to share these ledgers with your colleagues through any decentralized storage like IPFS or just common cloud storage. Second anomaly is reuse. According to Forbes, 80% of time of data scientists is still spent on collecting and preparing data. So super inefficient. In Kamu, we say that 100% of this work is bound to be repeated. You might have seen a lot of data sets on GitHub, Kaggle, Hugging Face being shared as improved data sets. So person goes to original source, they take the data, collect it from official sources, they clean it up, harmonize it, integrate it into some machine learning ready data set. So desire to collaborate clearly exists globally, but verifying such data sets takes more time than redoing the work from scratch often. The serious projects that are started, they always start from scratch from official sources. So the reuse is clearly broken. Our solution to this is verifiable computing. In Kamu, we clearly separate derivative data from the source data. So the derivative data is just a function of the source data. And we use cryptographic proofs to ensure that the results are verifiable in seconds, not in weeks or months. As a side effect of cryptographic proofs, you get 100% reliable provenance. So you always know where the source data is coming from. You can unravel the whole chain. So we're talking about big mindset shift here towards thinking that data without provenance is fake and should not be relied upon. In Kamu, we use verifiable computing. We basically created the wrappers on top of very widely used open source data processing engines. And we published how exactly provenance should be tracked and proofs should be tracked as open formats and protocols. Third anomaly is composability. So if we zoom very, very far back, this is my kind of artistic rendering of how the data ecosystem functions right now. Right now, there's only one degree of separation, usually. You're either a publisher of data or a consumer of it. And we have these small ecosystems forming around interesting data sets that mostly just don't interact with one another. If you look at the software, the picture is completely different. We have libraries built on top of thousands and thousands of other libraries. We have massive dependency graphs. So clearly, software reached the level of true composability and data did not. So what is different? And we believe that our foundational computation model is wrong. So our society mostly functions what we call batch data flows, where a person, like close to a data source, takes the data, processes it, reshares it with their colleagues in some new format. Other person picks this data up, transforms it into something else, reshares it again. So people are just constantly moving data, touching data manually, and this results in huge latency. Like think of meta research, right? It takes years. So the data you see and the data that decision makers use is actually completely outdated and is very its value significantly decreased. The solution here is temporal processing. So it's a new computational model for dynamic data. I cannot explain it now, but you can see my other talks where I go in detail. The quick gist of it is that in batch model operates on finite sets. So it expects your inputs to be consistent and complete. And this is almost never the case, especially when you're working with multiple data sources at the same time. Temporal data processing model operates on ledgers that are continuously evolving. So as your inputs evolve, your output is also going to evolve, and it eventually gets into a consistent state. So best analogy I have is it's like calculus of data. It's really significant innovation, and it's a revolution in enterprise data space that is now we're taking and using for open data science. I feel like for the last decade, I've been building these Rube Goldberg machines in batch that are super complex, manual, and fragile. Now we're moving towards the space of pipelines, super homogeneous, autonomous, and self-correcting. In batch data flows, as you can see, people are basically the cogs in the machine. They're on a hot path of the data that causes a lot of latency. People are just, by their nature, unreliable. In temporal data flows, we're extracting people from the chain. So people are becoming the designers and maintainers of the pipeline, but data itself just flows through these pipelines. It can flow through real time, even if you have thousands and thousands of different processing stages owned by different organizations and by different people. So this is the foundation of our Kamu node. This is how these data flows and pipelines look in our platform. And this is the platform that powers Molecule Labs project. Let's talk about effects. How I see it is that we spent last couple of decades in data space descending into local optima, this local optima of batch and inefficient data exchange. Now with temporal processing and verifiable computing combined, this defines a really interesting new space in data that I think we're going to be moving towards in the next decade or so. It has a really cool effect on systematization. Because of the ledgers, there's less copying, therefore less noise, and pipelines naturally self-organize around each other. So important data flows are being maintained, they're being cross-verified by the whole community. So we can reach the effects of open source revolution in software, but now apply it, reach the same effects in data. Really cool effect on life cycle of research this can unlock. So imagine you have some healthcare data publishers. They can publish data completely decentralized way, achieve sovereignty of data. By publishing data through these ledgers, they're basically held accountable for the data that they're providing. Some other researcher can find these publishers for you, combine them, and reshare with the network as a higher level data set. When you go and do your research, you can reuse the data from that researcher, and through the mechanism of provenance, automatically give them credit for their work. Then you go on to publish your paper. You can include a stable reference to this ledger, and the reviewer of the journal or a conference can verify all your analysis through this stable reference. Other researchers, not only they can reproduce your research very easily, but they can, because the whole thing stays as a pipeline, because it's still linked to the data sources that the data is coming from, they, with one command, can actually pull in all the new and latest and fresh data and recreate the research and see if your conclusions in your analysis still hold months, years, or decades after your research was publishing. So this basically gives a very long life to the research that you're doing. And as a cherry on top, again, because the sources are linked, if there's a significant retraction or a correction in the source that is happening, you can get notified through this pipeline about, okay, you might want to recheck your analysis, whether your conclusions still hold in light of these new retractions. Publishers are basically the weakest link in this model, and they require very special attentions in terms of incentives. And we basically believe that right now these incentives are not there. So right now it's basically economically not viable for small publishers to bring data. The current solution, like we have data DAOs that incentivize in Web3 for people to bring data and reward them for this. But think about, from publisher's perspective, how many steps this takes, right? This person needs to discover that your DAO exists. They need to prepare data. They need to submit it. Then they have to maintain it if the data is evolving. So this is a huge upfront cost and recurrent cost to the data publishers. Now we were talking about a lot of wearables, right? IoT data. This data might be useful for dozens or if not hundreds of different DAOs. And this basically cost multiplies for the publisher. So we're talking about collectively a quadratic cost to bring data to the system. This clearly doesn't scale and is not sustainable. So we're proposing to flip the model into something that composes. Data publishers can basically bring their data to the network. They just need to register it on a network. And this is where their job ends. Other people can discover these data sets by some labels and start accumulating them into higher and higher level data sets, combining them together. So, and feeding these data sets into data DAOs. Because the whole system preserves the provenance, verifiable provenance basically becomes this mechanism through which you can distribute the rewards. It can be instantaneous rewards for bringing data in. It can be subscription-style rewards for continuously supplying data from your devices. Or it can even be like equity that is far, far delayed, like you don't have to, in a rush, design a tokenomic system for your DAO because this provenance stays. Like it doesn't matter how much time passes, you still will know where every single bit of your data came from, and you can use this information to distribute the rewards much later. So I think this is a really cool, scalable mechanism for actually making data DAOs work. The same model works for Gen AI. Like right now, if you look at ChatGPT, right, they're cutting traffic to the websites that they're sourcing data from. This happens with Stack Overflow. Reddit is suing them likewise. So they're actually creating disincentives to publish data in the open while the whole world is starving for more data. So I think verifiable provenance is a solution for that as well. With our partner, Brian, we integrated Kamu into their LLM, that is focused on financial, like DeFi research. And they're basically sourcing data by communicating with our engine. They're basically sourcing data from us. So you can ask, like, what are the top DeFi pools to invest on Polygon? And it's going to give you a very terse, data-based answer based on real-time data. But more importantly, with every answer, you get not just the answer itself, but a proof of where this whole data is coming from. So you get the whole provenance of where it's, how this data was generated, through which data sets, etc. And you can think of this proof as always living as part of your agent history. It's always there. Even 10 years later, you can verify it and see that, okay, you can hold the whole system accountable for a very long period of time. So LLMs, this agent naturally prefers more refined and higher level data sets. And when it generates this proof includes the whole provenance of the whole system. So again, we can use verifiable provenance to distribute the rewards even in this system. So this is my conclusion. Research data is inseparable and vital part of the global data economy. I don't think we can solve it one without the other. The pillars of the new data economy are decentralization, composability, and verifiability. And we basically think that, yeah, after years of working on this model, that the problem is mostly solved. Now becomes a long work on the adoption. And to adopt this model, we need to change how we think. We need to stop thinking about data as this book in a library and think more about data flows that power our society. We need to stop treating ourselves as cogs in this machine and become these builders and maintainers of pipelines that connect these data flows together. So I hope you can give our tool a try. It's openly available. Go to demo.kamu.dev. And we have an open data science community on our Discord, so I encourage you to also hop in and give us, say hi to us. Yeah, thank you so much.